Heat. It's the cornerstone of an industry that has built the roadways of the world.
We employ these very high temperatures because the aggregate and asphalt would not blend otherwise. You could not get the asphalt, which is at room temperatures or at lower temperatures a very, very viscous, sticky material. You couldn't get it to coat the aggregate. Those temperatures, the rock temperatures, are commonly around 350 degrees Fahrenheit, and that's then mixed with asphalt, which is typically on the order of 325 degrees Fahrenheit.
The result is hot mix asphalt, and that mix must stay hot to be workable.
It has to be workable as the truck transfers this mix to a paving machine. It has to be workable as that paving machine extends it out across the width of the roadway that we want to build. And then lastly, it has to be, most importantly perhaps, it has to be compactable.
It's a process that works. Asphalt has always offered sound environmental and energy advantages over other paving materials. But in the midst of rising fuel costs and a sensitive environmental climate, the industry is always looking for ways to improve.
We represent the hot mix asphalt industry. We have about 1,100 members, and we see it as our role to be visionary, to look to the future. So our role has really been to stimulate technology.
Now this is the break point between E9 and E10.
Buzz Powell manages the test track at NCAT, the National Center for Asphalt Technology in Auburn, Alabama.
These included, and everywhere where you see a white mark going across the pavement, that's a randomly identified test location. This is an accelerator performance test, and the objective is to take 10 to 15 years worth of truck traffic and compress it into 2 years. That way we can produce results for the state-sponsored DOT within a very short period of time. These two sections were built around about November of 2005, and since that time they've had approximately 4 million easels applied to them, equivalent single axle loadings. In kind of simple terms, that amounts to about 3 million heavy axle passes.
In these sections, NCAT is testing the long-term performance of a technology that is redefining the basis of the asphalt industry. It's called warm mix.
Fundamentally, what's going on in a warm mix is that you have an additive through a chemical process that lowers viscosity. What's that mean? That means you need to use less heat to heat the material to be able to accomplish the same thing. That's warm mix.
Warm mix is really one of the new technologies that has caught the attention of the industry in a number of ways. There are really some significant benefits to warm technology.
Not only in the emissions and working conditions, but also in terms of the environmental benefits, in terms of saving fuel and energy, greenhouse gases.
Most of these benefits are directly related to a significant decrease in the production and application temperature of the asphalt. Some chemistries offer a drop of 100 degrees Fahrenheit or more, and that translates into tremendous fuel savings, up to 55%. And with that, a dramatic decrease in emissions. Carbon dioxide down 46%, nitrogen oxides down 58%, and sulfur oxides down an amazing 81%.
We're always looking for new and innovative ways to do things, and it comes down to dollars and cents.
San Antonio is one of the many municipalities exploring the use of warm mix asphalt.
Well, it's a big advantage for our workers that are out in the field when they're laying a lot of asphalt, 2,000 to 3,000 tons a day, and you can get the material at 100 degrees cooler than conventional hot mix. It can actually improve their productivity.
If you're going to work in an environment that typically is operating at 160 degrees C or so, it is an uncomfortable environment for any human to be exposed to. I mean, it's just hot.
So any temperature that you can mitigate with cooler mix, that's got to be a good thing.
When those trucks back up into the laydown machine and those doors open, with conventional hot mix you get this release of heat and fumes, and you don't see that with the warm mix. It's also good for our environment in San Antonio. There's air quality alert issues that go on during the summer, and this will also help us meet those requirements and not add to the pollution in our city.
If the city of San Antonio switched entirely to warm mix, it would save more than 1 million gallons of diesel fuel each year. If the United States switched, Fuel and emission savings would be equivalent to taking more than 1.5 million cars off the road. But in the end, none of these savings matter if the roadways don't perform.
The street that we're on now is Maryland Street. It's been down since April of 2007, and it is really performing well.
We were initially driven by all the environmental benefits that we saw from warm mix, but our experience in the field is that we're seeing many construction benefits.
The warm mix technologies across the board allow for improved densification.
We've gotten a really tight compaction on the street, which waterproofs the wearing surface.
You know, warm mix processes aid compaction. So the question was, the aid compaction, would it continue on into traffic?
This is just one of the questions being answered at the NCAT test track. After compacting the pavement at 180 degrees Fahrenheit, truck traffic was immediately returned to the track.
The warm mixes have performed extremely well. There's only approximately 1 millimeter of rutting in both of the warm mix sections. You know, 1 millimeter is almost an inconceivably small depth.
NCAT is not the only one testing warm mix. The Asphalt Institute is one of many research facilities conducting comprehensive laboratory testing. They're looking for signs of distress, water intrusion, cracking. But the real test is real-world performance.
Warm mix has been used under a wide range of environments, heavy traffic like at the NCAT test track, the entrance to a number of hot mix plants and areas, industrial areas in Missouri with slow-moving truck traffic, and it's performed well in all those cases.
With over a decade of international experience, hundreds of projects around the globe are proving the technology works.
Sections of the Autobahn in Germany have had warm mix sections down for 5 years under heavy traffic, and performance is good.
We did a major study tour in 2002. We took contractors across to Europe, looked at several technologies, and the results were amazing and dramatic.
One of the reasons the pavements are performing so well may again be tied to turning down the heat.
One of the consequences of conventional hot mix asphalt production is the production operation ages that asphalt an estimated 5 years.
So it's really the production temperatures that create the oxidation in hot mix asphalt.
And oxidation makes asphalt brittle. In laboratory testing, warm mix asphalt binders that have undergone 7 to 10 years of accelerated aging are exhibiting the same elastic properties of new hot mix asphalt.
We've discovered that there are other benefits that come from reducing our hot mix temperatures.
One of those benefits is changing another fundamental law of the asphalt industry.
With hot mix, you really have to worry about that temperature dropping too low and not being able to compact your material well once you're out in the field. But with the warm mix technologies, it takes longer for the material to cool down, and it has a wider range of temperatures that it can compact at and still reach good densities.
This flexibility means the paving season doesn't have to end when the weather cools down.
And this is really important where you have programs that didn't quite get done before the onset of a winter season.
Which is huge for a contractor who may have to generate much of his revenue during 5 or 6 months of the year.
Contractors are also pleased with how easily warm mix additives can be introduced into their product lines.
Other than temperature, we have seen no change between the operation of the plants. Now, we have had very good luck with the simplicity, not only the simplicity, but also the comparability and compatibility with hot mix.
Warm mix is not that different than conventional asphalt. When you're putting down warm mix, it's just as easy as putting down hot mix.
We have paved sections that are side by side, and you cannot tell the warm mix from the hot mix as an end product. We've just had very good success overall through the production of it.
People are very impressed with what we see with warm mix technologies, and we get density and we get a good performing pavement.
We see this technology as well on its way. We think this is the future for the hot mix asphalt industry, and it's just really a question of time in terms of how quickly we can move from hot mix asphalt to warm mix.
So I'm sold, you know, on the benefits and certainly the potential performance. This is a superior mix.